Hey guys, my name is Addy Osmani. I work on the Chrome team at Google, and today I'm going to talk to you about how to improve the rendering performance of your sites and web apps. This is an area that we web developers have only recently started paying more attention to, and it's important because it can actually have a pretty big impact on your user experience and your user engagement. Now, there are two really quick things I want to say before I get started. The first is that I'm probably not the best Googler in the world. I didn't skydive into Oslo this morning, and I feel really bad about that. It's because I'm terrified of jumping out of planes. I did, however, zoom in and out of a map of Oslo really, really fast, and I'm told that's the exact same thing. So you're welcome for that. The other thing I wanted to say is that whenever you're looking at performance, don't guess it, test it. Your best option is always to learn how to measure your application and understand what your code is doing. That way, when browsers change, and they're always changing every week, you're still going to be clear about what matters to you in your application, and you'll be able to improve your performance better. So with that, I'm going to head on over to Canary. So the other day I was on Pinterest, and I was trying to find some ponies to add to my awesome pony homies board, because I love ponies. So I went over to the Pinterest feed, and I started scrolling through looking for some ponies to add. Now, the first thing that I noticed as I scrolled through was that scrolling this page is just really slow. It's actually taking me some effort to scroll up and down. And the experience just feels really sluggish. Now, when users see this, they can actually get pretty frustrated, and that means that they're more likely to leave your app or your site. Now, this break that we're seeing in consistent frame rate as I scroll down is something that the Chrome team called jank. I'm not really sure what's causing this here. You can actually notice some of the frames being drawn on screen as we scroll through. Now, as a JavaScript developer, my first instinct is to think, maybe this is a memory leak. Maybe there are some objects that are hanging around after a round of garbage collection. The reality, however, is a lot of the time these days, our major performance bottlenecks come down to poor paint and rendering times. The DOM still needs to be turned into pixels on the screen. And if you're doing too much on, say, scroll, you can actually end up slowing down those paint times. So I suspect that there's something in this page that's affecting the frame rate. And so I'm going to open up the DevTools and head on over to the timeline, and I'm going to go to frames mode. I'm going to start recording a new session, so I'm pressing the record button. Now, I want to simulate a few minutes of usage, so I'm just going to scroll a little bit fast, so up, down, up, down, up, down, up, down. What you'll notice in the summary view up here at the top, where we've got these bars appearing, is that we're seeing a lot of green and a little bit of purple, and these correspond to paint and rendering times. So I'm going to just stop recording so we can actually take a look at what this data is. Now, if you take a look at the legend to the very right, what you'll see is that we've actually blown our budget for 60 frames a second. And there are many cases where we're not even hitting 30 frames a second either. Don't worry if you don't know what 60 frames a second or 30 frames a second are, I'll explain those quite soon. So we've realized that this page is performing quite poorly. Now, each of these bars that we're seeing at the top actually correspond to one single frame that Chrome has to draw in order to be able to get everything that you want on screen. Now, frame rate, so we're talking about frames a second a minute ago. So frame rate is actually the rate at which devices produce consecutive images to the screen. Low frame rates mean that individual frames being made out by our eyes, and high frame rates actually give our users a more responsive feel to the apps. Now, things like long image decodes, unnecessary image resizes, heavy animation, data processing, all of these things can actually lead to dropped frames in your app, which can result in jank. Now, if you're targeting 60 frames a second, which we say is the ideal number of frames that you should be targeting these days to match the refresh rate of most devices, so our phones, our tablets, our laptops, that means you have around 16.66 or 16.7 milliseconds to complete absolutely everything in. That's your JavaScript, your layout, your image resizing, your compositing, your painting, absolutely everything. Now, our ideal in this type of situation is being able to hit 60 frames a second. If you're aiming for sort of lower-end devices, if you're dealing with processors that aren't that fast, a constant frame rate is actually better than varying between 30 and 60. Now, a lot of the time these days, we're trying to build experiences for mobile, right? And on mobile, you actually have more like 8 to 10 milliseconds once you factor in slower processors, slower GPU, and things just not being as fast as on desktop. So just be sure to make sure to test out on the devices that you're targeting as a company. Now, going back to scrolling, I actually have a sneaky suspicion that there are some unnecessary repaints occurring on this page on scroll. Now, one common mistake we make a lot of the time these days is to stuff just way too much JavaScript into our on-scroll handlers. And that makes it pretty difficult for us to get any sort of frame budget, period. The heavier your on-scroll handlers are, the higher the chance you're going to experience some jank in your pages. Now, the best thing that you can usually do in these situations is actually just capture scroll top in your scroll handlers and use something like a request animation frame loop with a recent value there. So I'm going to go back into the DevTools settings. I'm going to try another feature out, and it's called Show Paint Rectangles. The idea behind this feature is that it allows me to visualize what areas of the screen are actually being repainted with a really nice red highlight. Now, pay attention to what happens as I scroll through Pinterest. Do you see that? We're getting a big red flash of red across the entire screen. What this means is that they're actually forcing a paint of the whole screen every single time that we scroll. Now, ideally, what you want the browser to be doing is actually just painting what's brand new to the page instead of the entire thing. So probably just the bottom part of the page. Now, the reason this seems to be happening is actually down to the little scroll to top button in the lower right corner. As you scroll, the fixed header at the top of the page actually needs to be repainted, but so does this button. Now, the way that Chrome specifically handles this is to do a union of the two areas that need to be repainted. So in this case, there's actually a rectangle from the top left of the screen to the top right. It's not a very tall area. And then there's another one in the lower right corner. And what this gives us is a rectangle from the top left to the bottom right, which is effectively the entire screen. Now, one thing I can do here, so we recently introduced a new shortcut in the DevTools, which is H, and that will basically toggle visibility on an element. So what I can do here is I can inspect that button, I can toggle visibility on it, and then scroll, and what you'll see is that only the header area is now being repainted. So the way to properly solve this particular problem might be to move the scroll button out into its own layer, so it's not getting unioned with the rest of the page. This basically isolates it, so it's not composited with the rest of the page as it's getting painted. We're going to talk a little bit more about layering and compositing in a bit. Now, the next thing I noticed on this page is actually to do with hover. When you hover over a pin on Pinterest, it displays this sort of action bar with a repin button, a like button, and a comment button. Now, what you see happening when I actually scroll is that it's not just sort of painting that bar, but it also seems to be repainting some of the underlying elements underneath it, which is perhaps not what I want. Now, there's another really interesting thing to do with scroll here. So I'm just going to sort of hover over this bar, this action bar that they've got. And let's see what happens when I actually start to scroll through the page. Do you see that? It's actually painting that action bar again and again and again, even though I don't actually need it. Hover is one of those things that actually amplifies your jank on scroll. So one thing Pinterest might be able to do here is maybe use like a set timeout with a delay to make sure that they're only displaying that bar when their users actually need it. They could probably also be doing some tighter checks on mouse enter to avoid those extra paints. Now, there's actually a really great workflow available for looking at the overall cost of paint in your page. And this is using another feature in the DevTools called continuous page repainting. And what continuous page repainting basically does is it constantly paints to the screen. So you're able to find out what elements in your page have got costly paint times. So I'm going to head down into my DevTools settings. There's actually a nice section called rendering in here, and I can just enable my enable continuous page repainting option. So let's enable that. Now, what you're going to see happening is that we get this really nice black box in the corner that highlights sort of the minimum and maximum paint times. Now, the way that you'd normally use this in your actual workflow is you'd probably head back to the Elements panel, and you start taking a look through the DOM tree, right? So here we can actually walk through the DOM tree using our keyboard. And if you suspect that there's an element with a relatively expensive paint, you can actually just use that H shortcut key once again to toggle visibility on the element and take a look at whether there's a corresponding drop in your paint times. Now, most of the time, you'll actually notice that there is a drop. There has to be a drop. If you're not painting as much, there's just going to be a drop. But what this is useful for is actually paying attention to whether there are elements with particularly expensive paint times that might bear some further scrutiny. Now, I can use this on pretty much any elements in this page. I can even, if I wanted to, go to the categories bar page element, hide that, and see what the drop in paint times are. What's probably more sensible is to toggle this on the categories bar. Now, if I want even more detailed insights, I can actually go right back into my timeline and record a new session to measure the impact of hiding those elements. As you can see, it's gotten a little bit better. Isn't that useful? Now, whilst this workflow should work pretty great for most pages, in Pinterest's case, it isn't as useful, actually. And the reason is that they actually have some pretty deeply nested DOM nodes in their page. That makes it really hard to actually dig really down into their specific pins and find out what's going on. But luckily, we can still get a little bit of mileage by taking a look at sort of specific elements. So here I'm highlighting, I've inspected this Doctor Who pin, and I can take a look at what styles this has in the styles bar. And I can start toggling on and off different properties to see what impacts they have on my paint times. Now this gives us a much finer grain of insight into the paint profile of our page. Now in this case, what are the properties they have? So they're using box shadow here. Now, box shadow is one of those properties that we've optimized pretty heavily in Chrome over the past 2 years. But if you're using it really heavily across your pages, and even in combination with other CSS properties, there's a chance that that might be a bottleneck worth looking at. So what we're going to do here is we're actually going to disable the box shadows, and we're going to go back into the timeline and measure whether that made a difference to the page. Now what you're seeing now, as opposed to what we had earlier, is that we're actually getting a slightly more constant 30 frames a second. This is closer to 60 frames a second. It's performing a little bit better on scroll. Now imagine if they actually went and started optimizing other parts of their page using these things. Now, public service announcement. I'm absolutely not saying don't use box shadow. By all means, please do. Just be sure that if you have bottlenecks in your pages that you're correctly measuring to make sure you're aware of what is causing the slowdown. And the reason for this is your site or your app, it might be unique. It might be doing something completely different that we don't know about. And your bottlenecks might be unique as well. Things like browser internals change almost daily. And, it's always better to be aware of how to measure rather than sort of focusing on these little rules about, hey, let's not use box shadow. That's not the case. Now, another thing that I noticed on this page, going back to the action bar, is if you click on the Repin button, let's enable show paint rectangles. If you click on the Repin button, do you see this? There's this light box effect, and it seems to actually be repainting the entire area on screen at the moment. Now, it's not entirely clear from the tooling whether this is the light box that's causing the issue, whether it's the white area, the white cover that's covering absolutely everything on screen, or something else. If you run into these types of situations, and you might well do that, just be sure that you're spending enough time measuring and you're not guessing what the issue is. My guess here might be it's the white cover, but that might not be the case. So, the next thing we're actually going to take a look at is show composite layer borders. So GPU acceleration is something that's quite interesting to me. In the past, web browsers have relied pretty heavily on the CPU to render pages. And this involves two things. We're going to get slightly into browser internals. Now, the first thing it involves is actually painting elements into a bunch of textures, and we call those layers. And secondly, we composite all of those layers together into the final picture that you see on screen. Over the past few years, and this is not just related to Chrome, this has been done in other browsers, we found that by getting the GPU involved with some of the compositing process, we can actually get some pretty significant speedups. The reason for this is that while textures are still being painted on the CPU, they can be uploaded to the GPU for compositing. And that essentially avoids us having to give the GPU any new graphics, and instead, we're just moving around things that have already been painted. That's something that the GPU is exceptionally fast at. And you can see some nice performance improvements if you're taking advantage of that. Now, there's no guarantee that any specific browser or any platform is going to have hardware acceleration enabled on it. It's certainly not the case. But if it is, many developers have found using the WebKit transform translate Z0 hack for sort of forcing an element into its own dedicated layer to be quite useful. It's particularly used for sort of like isolating an element so that it's not getting union when it comes to painting for the rest of the page. And you can get some nice speed improvements there. So there's another nice feature in the DevTools in settings called Show Composite Layer Borders. And this basically gives us insights into those DOM elements that are being manipulated at a GPU level. So, if an element on the page is taking advantage, you'll actually see a nice orange border around it with its own. So as we scroll through, I'm not actually seeing any elements other than the scroll bar, which is part of the browser, that's taking advantage of composite layers. Not the scroll to top button we had in earlier or anything else. Now, Chrome is actually getting pretty good at handling automatic sort of layer promotion in the background for you, but developers can get some mileage by using hacks like these. You just have to be careful when you're using them. So one thing we're going to do now is we're going to add WebKit transform translate Z to pretty much all of the pins on this page and see what happens. So let's do that. Let's head back into the timeline and let's record a new session. Now, if you take a look, we're hitting 30 frames a second. We're fairly constant. But one thing that you need to keep in mind here is this hack, whilst it's working pretty okay here, once you actually start applying it to hundreds and hundreds of elements, you're going to end up seeing an amount of slowdown. The reason is it's not supposed to be used on every element on the page. If you do that, you're going to realize pretty soon that the GPU has actually got some pretty limited VRAM, and exhausting it can actually have a negative impact on your performance. So instead, only use hardware compositing or layer promotion in those cases where you've got elements with a measurably high paint cost. So with that, we're going to stop poking Pinterest with a stick. I imagine that quite a few people feel, I guess, a little bit like this. Nicolas Cage stuck in the DevTools wondering what the hell is going on. I know some of this stuff is just really new to a lot of people. It blew my mind when I first learned about it. And my hope is that by the end of this talk, you're going to feel a little bit more like this. Nicolas Cage, when he's just, he's Con Air, he's just broken out of jail, he's happy, everything's good. So let's slow down a little bit, right? So let's talk about jank on the web. So what defines a great web experience? Everything works. Shit's gotta work, otherwise none of this performance stuff matters. Ideally, you've got a snappy experience, you've got silky scrolling, you've got smooth animations. Users don't notice these frames being dropped as they're using your application. You've got great performance on desktop and on mobile. It doesn't matter what device you're accessing your site or your app from. And typically this means that you're actually hitting a pretty good frame rate. Now, what does that mean? So I mentioned the idea of consistent frame rate earlier. Now, frame rate, as I said, was the rate at which a device produces consecutive images to the screen. Now, you're probably familiar with frame rate if you're a gamer, because anytime you're trying to run a game, you ideally want a really great frame rate. You want it to be fluid. You want it to be high resolution. When you notice frames dropping, that experience just doesn't feel as nice. It's not as pleasant. So a low frame rate means that individual frames can be made out by our eyes. Jank, that term I used earlier, is a disruption in that consistent frame rate, and it manifests itself visually. So your users can actually notice frames being drawn on the screen. So ideally, we want to be hitting a high frame rate for our apps and our sites to be pretty responsive feeling to our users. Now, if the Pinterest demo didn't really, convince you, let's take a look at another one, if this actually loads up. So this is one that I think most people will actually notice a difference of. This is what bad animation looks like. Basically, we're probably not hitting more than 10 or 15 frames a second. If this is what you were targeting, sure, it looks okay. But if I stop that, compare that to this, which is so much more fluid. You're not seeing any sort of frames being dropped. It's hitting 60 frames a second. Would you like to know what's actually causing the difference between the bad and the good version of this? Let's dig down into this. Let's head on over to DevTools. Let's go to sources. Let's go into the sources for this page. Now, there's one little property that's actually responsible for the slowdown in this case, and it's offset top. Offset top happens to be one of those properties that triggers layout in Blink or in WebKit. There are a number of other properties that can do this, accessing offset width, outer text, scroll width, scroll top, and so on. Don't take these as hard and fast rules. Make sure that if you think that you're using one of these and it's a problem in your application that you're accurately measuring, what you want to be keeping an eye out for are these purple bars, which represent sort of layout and style recalculation. So in our case, the way that we were able to improve the performance of that specific demo was by changing the way that we're doing our math. Rather than relying on offset top, we changed the way that we were doing the math for the page, and we're able to hit 60 frames a second instead. Why should you care about consistent frame rate? It gives you the difference between a native filling application and an unpolished one. I want the web to win, but when I pick up a phone and I'm scrolling through an application when I'm trying to do something, that's a really beautiful fluid experience. I want that for the web apps that we're creating tomorrow and the websites that we're creating tomorrow. Frame rate can actually also directly impact your engagement and your conversion rate. Now here's a very quick case study. So a few months ago, I was at EdgeConf in London, where Facebook sent some of their engineers, and they said that in an A/B test, they actually slowed down scrolling from 60 frames a second down to 30 frames a second, and engagement collapsed. They did this on a fairly small population of users. I think it was like 13 million or something like that. That's crazy, right? They were able to do such an interesting A/B test on a large number of users. And they discovered that, so this was on their native app. They said that they assumed that the same applied to their web application. And it was the case that 60 frames a second performed best, and 30 frames a second, when constant, performed second best. So if you can't hit 60 frames a second for whatever reason, strive for a constant 30 frames a second instead. Because frame rate matters if you want engaged users. So target 60 or 30 where possible. So why target 60? What's magical about this number? Well, animation should ideally try matching the refresh rate of the devices that they're being used on. And the average refresh rate of many of the devices that we're using these days and we're targeting these days is actually around 60 hertz. So my phone, my laptop, all of these are actually roughly have 60 hertz. That's not to say that there aren't devices with much, much higher refresh rates. There are. But just keep in mind that the rough average is around 60. And browsers like Chrome will actually cap your frame rate based on your device refresh rate. So what do these numbers mean when I talk about sort of 15 frames a second and 30 and 60? At roughly 15 frames a second, your users are going to perceive some amount of jank and jitter in your pages. At 30, you can probably provide them a relatively silky smooth experience as long as it's constant. You don't want to be varying between 30 and 60 because that's when they're going to start seeing drop frames. And at 60, we're able to hit that nice sweet spot of smooth animations and transitions without any stutter. Now here's another quick, very, very quick demo if this works up. Let's see. So the Wi-Fi isn't liking me. Let's skip that. But basically what I was going to show you was what it would look like if I had something animating at 60 frames a second, at 25 frames a second, and 10 frames a second. And it's actually really easy to notice the difference in frame rate. So ideally you want to be hitting as high as you can. So let's talk about frame budget really quickly. Now at 60 frames a second, you have about 16.7 milliseconds of time to get all of your logic processing, your compute processing, and your rendering completed in. Unfortunately, down to browser processes and a lot of miscellaneous stuff happening in the background, and to account for mobile, you more have like 8 to 10 milliseconds. So if you're blowing that budget, chances are you're going to end up seeing some slowdown in your page. And what's interesting about things like mobile is that some operations are anywhere up to 6 times more expensive. So parsing HTML, it's 6 times more expensive on mobile at the moment, which is crazy. So it's important to keep all of these things in mind when you're developing for a world with multiple devices. So what types of things cause jank? Triggering layout and style recalculations when you don't really intend to. A lot of people I've seen have actually been using JavaScript to rearrange their pages, trying to give sort of these really beautiful layouts. You know, you scroll, you change the size of the window, all that stuff, and they'll use their JavaScript to modify what the page layout looks like. That's actually a really expensive operation, particularly if you're doing it on scroll. Now, you've probably run into this at some point if you've ever looked at a parallax site or one of those portfolio sites where they're just doing so much stuff as you scroll down the page. That's never good. Always try to measure and keep an eye out again for those purple bars, because those represent the layout and style recalcs. Heavy on-scroll handlers is something you ideally also want to be avoiding. Now, one thing that some people I've seen done have actually been sort of, so let's take a look at this. So I'm not sure if you can tell this. It's really, really difficult for me to scroll down this page. I am struggling so much to scroll down this page. And it's because I just have so much stuff currently happening on scroll. I've got a lot of logic processing on my on scroll, and it's just slowing down the rest of my page. When I add in costly effects into the mix, it gets even slower to scroll down. Now imagine what this must be like on mobile, where we don't have as fast processors. It's going to be a little bit crap looking, really, and you don't want that. Now this was one that really surprised me out. Things like long image decodes and resizes actually have a really big hit on the performance of your pages. Something we like to do is say, okay, well, I'm going to use a really big image and I'm going to have the browser just scale it down. It'll look fine. And that's going to be my solution regardless of the device they access it from. If it's Retina, great. I'm sure it'll look fine. But the browser actually has to decode those large images and then resize them, and that takes a while. I was actually profiling a Daft Punk page recently, and they actually had images that were 2 or 3 sizes times the size that they had to be. So remember to pre-scale your images if you're doing something that's pretty intensive visually, because that can be another bottleneck in your pages. Again, make sure to measure. DOM elements with a measurably high paint cost are another thing to look out for. Measure what elements are slowing you down, because if you have a deeply nested DOM and you're just doing so much stuff inside that page, that can be a bottleneck. So keep an eye out for it. Doing too much inside your event handlers. Now this is something that I think is slightly more rare these days, and I'm glad to see it. Now this is an example where we're just doing, look what we're doing as I move across the screen. It's like the best app ever. Seriously, every single time that I move my mouse, I'm changing coordinates, and it's having to do a ton of different recalculations to display this animation. That's ridiculous. On some operating systems, input events can actually arrive as often as 2 milliseconds. So I'm doing something every 2 milliseconds that's going to change what this performs like. And the reason that this is a problem, let's actually, I can talk the talk, let's actually measure what happens here. Let's take a look at this. It's not hitting 60 frames a second. What we've got here is we've got a lot of different scripting. We've got some style recalculation. We've got rendering and layout. Now, if you take a look at what this actually breaks down into, there's lots of different steps that's happening. There's style recalculation, layout, paint, compositing, and then we actually have another bunch of stuff that's happening as I move across the page. So just try to be careful when you're designing your interfaces so you're not doing, too much stuff in there. Heavy animation or data processing. Where possible, always rely on request animation frame or web workers. Also make sure that there are no event handlers that might be causing you issues with your RAF callbacks, and keep them short. If possible, try to keep them under 15 milliseconds on mobile. Because heavy animations are another thing. We love to make things look visually beautiful on the web. And there's nothing wrong with that, but just make sure that you're measuring that performance isn't going to stop people from being able to use your app or your site. Because that's going to make them leave. And just generally doing a little bit too much at once. JavaScript is single-threaded if you've got timers fired or you have input handlers running. And there's a chance that your request animation frame callback might just not run. So here I actually have a bunch of stuff that I'm doing, and I've simulated the sleep function. So look at what happens when I'm just doing way too much in my page, and I'm introducing jank, 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 jank. And imagine if this was on a loop, you'd constantly be seeing jank in your pages. So ideally, you want to avoid doing this. These are lots of little pro tips that I hope will be able to help people. Let's quickly talk about page render weight. Now, a member of my team, Colt McCandless, recently tested 48,000 combinations of different CSS properties, which is crazy. And he proved that some properties are actually just more expensive to render than others, which is something that we thought might be the case for a while. Now, take a look at this diagram. So this is from a few pages that we set up for testing. Now, one that was just using box shadow. Now, the timings weren't too bad on there, 0.22 milliseconds. Border radius stroke, 0.27. That's fine. Interestingly, when you combine them, you'd expect there to be some sort of sum of their cost as being the final one, like maybe it's 0.4 or 0.5. The reality, however, is that it's not the case. Combining these two properties together ended up taking 1 millisecond, over a millisecond in time. So some CSS properties may have a high paint cost. Now, when I say this is specific to Chrome. It may very well be the case that things differ in other browsers, so make sure that you're using their tooling to get a good feel for what the browser landscape might look like. Also keep in mind that all this information is correct as of today, and browsers are constantly changing, so some of this information might go out of date. Border radius is one of the most expensive CSS properties to affect rendering times, mainly because of repaints. Transforms, really expensive. Linear gradients. I hate to say this, but there are cases where it's actually better for you to use an image rather than relying on linear gradients in your pages, because those don't require as much sort of intensive processor work in order to render. Box shadow. Now, box shadow, as we saw earlier on Pinterest, it's one of those properties that if you're using it lightly, that's not a problem at all. But if you're using it intensely across your entire page and on every single element, that can be a bottleneck. So just be aware that might be an issue, and just make sure to measure to check that if it's an issue in your app. Fixed background actually has another large repaint cost, and it can kill your scrolling performance. Let's talk about paint and compositing really quickly. So what do I mean when I say a repaint? Repaints are basically when you have to update the screen because something in the page has changed. Someone has been trying to change the layout via JavaScript, or some CSS styles have been triggered. Maybe you've been hovering over something and it's been changing styles. That's going to result in repaints in your page. Those changes basically invalidate the entire rectangle that you see on screen. So everything that you see in your browser, consider that a rectangle. When you make changes, that invalidates it. It means that it has to be repainted. We call that, in Chrome world, we call that a damage rect. Now, repainting is generally an expensive operation. It can make your page sluggish. It's also really necessary. We can't give people experiences on the web without repainting. It's not possible. The key is to make sure that your repaints are as small as possible, and you're not making them happen across the entire page, as we saw earlier. So things like your DOM node changes in JavaScript can cause the layout, and they can cause repaints. Interactions like hover, those can cause repaints. Quick question to the audience. What needs to be repainted as this yellow block animates? How many people think that one thing needs to change? Depends. Why do you say it depends? Yes, I'm going to be getting onto that in just a second. 2 things? A few hands? 3 things? More hands? 4 things? Few hands? 5 things? I got you out because it's not possible. Right. Now, we have this concept of a backing store. I'm not going to explain a backing store too much, but consider it sort of this buffer that we use for drawing things on the screen. Because I'm in DevTools land, and this is basically a talk about DevTools, I can't not, have some fun here. And so what I'm going to do is I'm going to go into my background. I'm going to change the URL of this, and we can have, Nicolas Cage spinning around instead. The answer to that question is actually that we have to draw portions of all 4 layers once again. You're invalidating the red box in front, the yellow box needs to be repainted, the blue box, and the gray layer as well. So whoever said 4 is actually correct. Now, compositing is basically this idea of using multiple backing stores, so multiple pixel buffers, to store and cache chunks of something called the render tree. So every single DOM node that you have in your page that has some sort of visual output is going to have something called a render object. We compose a render tree based on those objects, and then we call a paint method to actually draw them on the screen. Now, if yellow and red actually have their own dedicated backing stores, so let me refresh this really quickly so Nicolas Cage goes away. If yellow and red have their own backing stores, then nothing actually needs to be repainted during animation. Your next question is probably, how do I actually make that happen? So let's talk about GPU compositing in a little bit more detail. So GPU compositing is this idea where we can get the GPU involved with compositing the contents of a web page. And some of the hacks that you can use to sort of force an element into its own composite layer are these. So WebKit Transform translates Z0, and WebKit Transform translate 3D. Yes, these are WebKit specific at the moment. These will basically turn on GPU acceleration, and they will force your element, if you want to isolate it away from everything else that's being repainted into the page, into its own dedicated layer. And it'll get its own backing surface as well. Now, some of you may be familiar with Mr. Doob. He's an amazing visual artist when it comes to creating things for the web. But let's take a look at, let's go back into our settings. Let's enable our show composited layer borders. Now, he actually found that his animations were running pretty sluggish. And so he basically applied that same hack to all the different elements on this page that were animating. Nothing else, just the ones that were animating. I'm not saying that's a best practice at all. I'm just saying this is what he did, and it worked for him. And he found that it actually ended up speeding up his animations, and it gave people a more fluid experience. In your cases, you'll probably end up finding out that there are some specific things in your applications and your sites that are slowing you down. So consider, maybe looking at what impact moving some of those things into their own layers might give you. Forcing layers might not be right, just be aware of the trade-offs, because if you apply it to everything in your page, you can end up seeing slowdown. On iOS, they actually disabled those 2 hacks, but there are some workarounds available. You guys can check out the slides later if you want to try those out. So let's review really quickly some of the tools that I talked about earlier. So show paint rectangles, that basically lets you visually see what areas are being repainted on screen. You can use it by modifying single elements in the DevTools, and you'll only see the rectangle of what's being redrawn. Now I'm going to be showing you this on mobile if it actually loads up. Okay, network's down. Okay, that's not working. All right, let's forget about that. Basically, I was going to show you a demo of a Nike parallax site that is basically repainting quite a lot of their animations. Show composited layer borders, which you were talking about earlier, basically helps you get insights into the structure of composited layers. So if you are promoting things to their own dedicated layers, this will basically confirm that they are getting promoted correctly. And if you're playing around with someone else's app and you're wondering whether or not they're taking advantage of these hacks, this will also help you there. So Wi-Fi is still down. Let's assume that that was an amazing demo. Right. Continuous painting mode basically helps you identify what elements are costly on your page. And it puts the page into the state where it's constantly repainting, and it gives you this really nice counter of how much paint work is happening. So that's another really useful tool to be using. And I'm not just going to be talking about Chrome. That would be wrong with me. The paint tools in other browsers have actually been getting much better these days. In the WebKit Nightlies, you've actually got this really nice new layer tool where you can select different elements in the page, and it'll tell you if they were given their own composite layer automatically or someone forced it, it'll actually summarize why they were given their own layer. So in this case, in the screenshot, I'm not sure if you can see it or not, one of these elements was given its own composite layer because it had a 3D transform, it had backface visibility hidden on it, and it was overlapping with another element. So this is something you can check out on the WebKit Nightlies. They've also got this other really nice feature where you can actually see how many times a specific layer is being repainted. So in the case of maybe, the header we were looking at earlier with Pinterest, using this you could actually see, okay, well, how many times is this being repainted? Is this an issue for my application? Do I need to be doing something differently? And Firefox have actually introduced a really neat feature called paint flashing, where you can see what areas of the page are being painted, and they actually use multiple colors to illustrate this, so it's really, really nice and visual. So I love that work that they recently did. Now let's talk about workflow, because that's what you care about, right? This stuff is all great, it's awesome demos and everything, but you care about how you can apply this to your apps. First thing you need to do is make sure that you're in incognito mode. If you're doing any sort of performance profiling in Chrome, make sure you use incognito mode, because otherwise any of the extensions you have installed, any of the apps you have installed, all of those can actually interfere with your profiling figures. So first of all, make sure you're doing that. Open up your page and the DevTools. Head on over to the timeline, record and interact with your page. This is stuff you guys are probably already familiar with. Check for your frames that went over budget. What wasn't able to hit 60 frames a second? What wasn't able to hit that nice constant 30 frames a second if 60 isn't possible? If you're close to budget, you're likely over budget on mobile. So be careful about that. Make sure that everything is happening within that 8 to 10 millisecond period that we were talking about earlier. Check what the cause of your jank was. Was it a long paint? Was it CSS layout? Was it your JavaScript? Then to fix the problem, go back into Settings, enable continuous page repainting. Go to the Elements panel. Start playing around with your DOM tree. Hide anything that you consider to be non-essential to your page using the H shortcut key. Take a look at that box. See if there are corresponding drops in time, significant drops in time. That's like a performance smell. It'll tell you, okay, well, maybe you need to spend more time looking at this. Walk through the DOM tree, hide those elements. Check your frame rate and timeline as well. And you'll hopefully be able to discover what elements are causing you long paints. As we did with Pinterest, uncheck styles that might be able to impact your paint times and recheck your frame rate. And continue until you've located those elements that might be responsible for your slowdown. And we can't have a talk without discussing mobile really quickly. So I'm introducing this concept called mobile-first performance benchmarking. Your frame rate on desktop is very, very rarely what it is on mobile. Again, down to, just the devices not being as powerful. Test on your low-end hardware. Make sure you're getting 60 frames a second there, because it's actually easier to start off from the low end and have a great experience there, which will work fantastic on desktop, than it is going from an experience that works great on desktop and having to hack on it until it works okay on mobile, and then good on mobile, and great on mobile. That's something that I learned the hard way, and it's a tip that I hope will help some people. So, thanks to international data roaming, I am going to be able to show you another demo. Okay, I'm going to just use plain terminal instead of iterm. Okay, so what I'm doing right now is I'm using DevTools remote debugging. The experience I'm going to be showing you is something that works pretty good on desktop, actually. And I've just been given some different Wi-Fi details that I'm going to try out really fast to see if these work. Yeah, please don't steal these details. I'm just... Small letters. The internet is hard. We should all go shopping. Sorry. Oh, T, that's a T. Yes. Yeah, internet. Right. Excellent. Right. So what I was going to show you earlier was this experience. Let me turn on my show paint rectangles really quickly as well. So this is actually a site that Nike created a while back. And it's filled with animations. Take a look at this. Isn't that nice? We've got some nice flashing going on as we keep moving through this experience. It just keeps going on. Now this actually works really, really well on desktop. It works beautifully. They've actually taken the time to properly sort of promote some of their layers that they found to be costly. And it just looks really great. It's actually really fluid. Despite these paint rectangles that I have on and the composite layer borders. So I'm going to disable those. That works really, really nice. What doesn't work as well is this experience on mobile. So let's take a look at what it looks like. So I'm going to apologize for you having to see my face up, just like close up. Right. So this is the experience on mobile. Now, what we're going to do is we're going to head on over, because I've already run that line that will allow me to use sort of remote debugging. I'm just going to go to About Inspect. And as you can see, I have Galaxy Nexus, so my phone, listed there. And I'm just going to click on Inspect to start inspecting it with the DevTools. Now, I'm going to just make sure that these two windows are actually side by side so you can see what I'm doing as we profile. So here's the application that's running. Head on over to the timeline, frames mode. And now I'm just going to start playing around with this. And I want you to pay attention to what is happening. Do you see that? It's actually taking a while for this thing to properly animate. I'm not doing anything differently to what I was doing on desktop. But it's taking a while for this thing to properly animate, and now it's stuck. It's going a little bit further. I'm going to end up spending 10 minutes trying to look through this web page. Let's take a look at some of these things earlier, right? So what we're seeing is a lot of work being done. Let me try to zoom in on this a little bit. We're seeing is just a lot of work being done. There's a lot of work being done in timers and so on as we're trying to scroll through. Now let's try to find out what is going on here. Well, it looks like there's actually just thousands and thousands of little events that are getting fired off. Let's dive into here. So it seems that they might actually have some sort of memory leak problems here. But the experience is just not as fluid on mobile for some reason. We can try this. Wow, this is slow. So we're seeing some layout, we're seeing some paint issues. And this is something that might be worth taking a look at. So here it seems that they are using composite layers, but they're actually taking a while to properly render. And so it might be worth them paying closer attention to some of the performance issues. Now, one thing that I thought was potentially better than giving me an experience that feels choppy is potentially just giving me, you know, this. I realize this is extremely basic. This lets me look at the shoe and buy it. That takes me 10 minutes. That means they make money. I prefer that right now. Until they can actually optimize, I prefer that. But as always, it always comes down to measuring correctly. Don't take anything I've said, you know, as a rule of thumb in any way. Please measure, find out what the performance bottlenecks in your own apps are. Because rendering, paint, these things are the next big frontier for performance. So frame rate matters and it can impact your engagement. Paints are a big problem, but luckily there's tons of tooling available to help, and not just in Chrome. Check your performance on both desktop and on mobile. Make sure they're fantastic on both. And if all goes well, this could be you. You could be Nicolas Cage dancing with a bear. That's it for me. Thank you. Questions? Lots of questions. Wow. Where do we start? Do we have a runner with a mic?
Yeah, hi. I'm Martin from Sweden, and I have a question about the remote debugging. Mm-hmm. It's really neat. Sorry, too much coffee. I was just wondering, are there any plans on getting that to iOS? Because we have a lot of customers working on iOS devices. So
there's actually, I can't comment on that. What I can say, however, is that there's some great tooling to help you with some of the paint performance issues here. There's actually a fantastic tool by a colleague called Unbug on Twitter called MiTool. That's M-I-H tool. And that gives you this really nice sort of browser that you can install on your iPad or your iPhone. And it actually has a lot of the tooling that I was showing you today baked in there. So it's basically a version of WebKit. You can go, you can check, check your paint performance. You can see, what is causing you issues. You can take a look at your composite layer borders, all of that stuff. So if you're stuck with iOS and you're trying to figure out what to do there, MiTool is definitely worth checking out.
Thank you very much.
One more? Hi, my name is Jørn Ara. I'm from Compositing. I have a question regarding your first Pinterest demo. Mm-hmm. And you hit this little scroll to top box, and you got a big performance gain of that. Mm-hmm. Would you get something similar if you put transform 0 on it?
That was the suggestion that I made. Basically, if you promoted that little box to its own composite layer, that would probably be a much better fix than just toggling visibility on it. Because if you're getting rid of it, obviously that's not a solution. So yes is the answer.
Yeah, thank you. That's it. Best question.
Great. The iOS one was actually pretty good.
Okay.